Okay, continuing in factors affecting airport capacity, next we'll talk about separation requirements. Separation requirements refer to aircraft weight categories. Aircraft weight is based upon the aircraft's maximum takeoff weight. And note this, that is the maximum allowable takeoff weight, not the actual takeoff weight. So for categories, it's based on the maximum allowable aircraft takeoff weight. You can't lightly load an aircraft, for example, and have your aircraft wake category be in one of the lighter levels. So wake categories go along with aircraft type and the maximum takeoff weight that is allowable. Aircraft wake vortices are dangerous to in-trail aircraft, so these minimum separation requirements are in place to make sure trailing aircraft are not impacted. This, however, affects airport capacity because when more distance between aircraft is required, less aircraft per minute can land. Minimum spacing required between aircraft, as you can see from this chart, is a factor of both the leading aircraft and the following aircraft. Weather changes continually and greatly impact airport capacity as well. Cloud height and visibility determine whether the airport can be operated with visual flight rules or instrument flight rules. Visual operations greatly increase airport capacity. For future planning, historical trends can be referenced to estimate the number of days a particular airport might be under visual flight rules or instrument flight rules. Winds also impact airport capacity depending upon the runway layout, as the winds dictate runway use. Aircraft mix. This refers to the similarity of aircraft using the airport at a given time. Big airplanes mixed with little airplanes, mixed with fast airplanes and slow ones all this mix increases air traffic control workload and impacts airport capacity. With a greater aircraft mix, it decreases the airport capacity. Wouldn't it be nice if aircraft operations at an airport were spread evenly throughout the day? In reality, though, especially with the hub and spoke route structure, aircraft arrive and depart in what we call banks. Arrival banks and departure banks. Airports suffer similar phenomena as rush hour traffic on city streets. There's rush hour into town in the morning, rush hour out of town in the afternoon. Aircraft have the same phenomena, the same problem in their arrival and departure banks, especially at hub airports that serve a hub and spoke route structure. As aircraft arrive and depart in banks, airport capacity is met or often even exceeded. Between banks, then, airports operate under capacity. Of interesting note, a runway can accommodate more departures per given unit of time than arrivals. Arrivals require the aircraft to slow and exit the runway, so aircraft have less runway occupancy time during departures. During a departure, an aircraft will taxi onto, line up and wait, or go ahead and take off, but the runway occupancy time is less during departures. Therefore, arrivals require more time, more runway occupancy time. The technology, skill, training, staffing of air traffic control also greatly impacts airport capacity. Your presentation gives a link to an overview of the FAA's next-gen air traffic system and goals of that system. I encourage you to take a look at that and become familiar with the future of the National Airspace System. Finally, noise, environmental considerations, these also impact airport capacity. Noise, believe it or not, is the most prominent environmental factor currently, but there are others. After wind and visibility criteria, an airport's runway configuration may be determined by noise criteria. Your presentation gives you a link to more information on noise considerations, so please take a look at that as you go through your presentation as well. In the next video, we're going to see mathematically how these factors impact an airport's capacity.